In the Arduino test, releasing button 1 starts the rest of the code. The potentiometer turning changes the speed of the smaller motor. The valves can be heard clicking when button 3 is pressed. The distance from the IR sensor increases the speed of the larger motor if an object is closer. The solenoids in the valves are turned on when button 2 is pressed, and they are turned off when button 4 is pressed. The serial monitor shows the state of the encoder, as well as all 4 buttons, the motor speeds, the IR distance, and the potentiometer reading.
In the Arduino test code, button 1 is checked at the beginning of the loop to initiate the remainder of the code. Once the trigger is received, a stop time of 20,000 milliseconds after the current time is set. Then another if statement, which checks whether the stop time has been passed, is run, and if it hasn't, then the main block is started. In the main block, the indicator LED is switched, and the buttons and sensors are all red. Then, the motors are set to the speed that corresponds to the values from the IR sensor and the potentiometer. From there, the values of all the sensors, buttons, and motor speeds are printed to the serial monitor. Finally, a check is done to see whether any of the buttons are pressed and different combinations of the digital pins are activated and deactivated depending on which buttons are pressed. Finally, if the time has elapsed or if the initial button has not been pressed, all of the digital pins and monitors are turned off. In the actuator test, the valves can be heard opening and closing. The motors spin back and forth repeatedly, and the electromagnet in the solenoids are continuously turned on and off.
In the actuator test code, the digital ports 1 through 4 are set to the off position, and the motors are set to a speed of 0. After a 1000 millisecond delay, they are all turned on and the motor is set to its max speed of 255 before another 100 millisecond delay. The final if-else statement switches the direction of the motor to be opposite of whatever it was prior. Each time the long arm button is clicked, the solenoid flips between on and off.
In the actuator switch code, the variables for button state and check state are defined and the serial monitor is set up. Then a loop is entered where anytime the button state is 0, then the state of check flips, which controls the state of the solenoid. There is a 200 millisecond delay to make everything run smoothly and deal with the switch bouncing issue. In this setup, the encoder controls the speed of the motor and the 2 switches control the direction of rotation. The LEDs on the board indicate either clockwise or counterclockwise rotation.
In the motor control encoder code, the encoder function is created. Then the setup function defines the outputs of the encoder. Then a loop is entered in which the output from the encoder is scaled to increase motor speed by 10% for every rotation, and it constantly checks the button states with 2 if statements. The states when both buttons are pressed or unpressed results in no movement. Each button corresponds to a different direction of rotation, which also triggers 2 different corresponding LEDs on the board. It is important to note that button 1 is normally on, so we set the if statement to account for this. There are 100 millisecond delays at the end of each if statement to make sure everything runs smoothly and to address the switch bouncing issue. When Captain America enters the zone 6 to 10 centimeters away from the IR sensor, the motor spins for 10 seconds. The banana plugs can be used as a kill switch to stop the motor.
In the IR banana plug code, the robot initially reads the values from the banana plugs in the IR sensor. It then checks to ensure that the banana plugs read a value of 0 and that the IR sensor is within the calibrated values of 260 to 375. If it is, then a for loop is activated, which checks every 100 milliseconds whether the banana plug is deactivated. If the banana plug kill switch is activated, the for loop is exited and the motor speed is set to 0. When Captain America enters a similar zone to the previous test, the motor spins for 10 seconds.
The ultrasonic banana plug code function works similarly to the IR banana plug code, but the key difference is that this pulls ultrasonic data from the sensor. This reading is not very accurate. It was reading a distance of 4 centimeters when the object was at 6 centimeters, and a distance of 6 centimeters when it was at 10 centimeters. However, the values did scale linearly with the distance from the object, making it more accurate at low distances than the IR sensor, which would have trouble at distances less than 4 centimeters.